Ellie here. Today, I am doing a caramel experiment. The amount of heat applied to sugar will affect the degree of caramelization. So today we'll be making caramel using sugar, butter, and heavy cream. In caramel, we are melting sugar and then cooking it until it goes through a process called caramelization. The sugar, which is made up of building blocks known as molecules called sucrose, they typically want to fit together like Legos and build a crystal structure. But for a smooth, chewy caramel, we want the solid to stay amorphous, meaning not stay in a particular pattern. To do that, we have butter and heavy cream that have a lot of fat to act like stuffing Play-Doh between your Legos and keep them from fitting together. This keeps your caramel from turning into crystals. In this experiment, it will be controlled through measuring temperature. The fact that when a liquid is boiling, it's going to stay at its boiling temperature. Water by itself will always boil at 100 degrees Celsius, which is 212 degrees Fahrenheit. And adding sugar can change the phase transition temperature of materials. As the sugar concentration rises, the boiling point increases. So we can use the temperature of our caramel with the liquids in it to tell how much water is left and how much has already evaporated. Temperature of sugar and how much water in that solution corresponds to the texture of caramel. So this caramel was at 222 degrees Fahrenheit, which reaches the first step, our process, that is known as the thread stage. If you place a drop of caramel in a cold glass of water, the syrup forms loose threads. Yes. As we continue to cook, the caramel will be removing water through evaporation. This means that the percent of sucrose in our caramel is going to increase, which is also going to increase the temperature of the boiling point. This is the reason that we'll see temperature increase on our candy thermometer as we keep boiling the caramel and removing water. This temperature change tells us how much water is left in our caramel, therefore how hard the caramel is going to be when it cools. So our next stage is the softball stage. So the softball stage occurs at an estimate of 234 to 245. Again, at this stage, if caramel is dropped in a cold glass of water, it will form into a softball, giving all the stages their names. This is a good texture for soft caramel. At this stage, it is the starting point of some of the browning color, which I feel like it was kind of brown already, but apparently, since caramelization happens at a much higher temperature, the reaction that's darkening the caramel now is called the Maillard reaction, which is toasting some of the milk solids in the butter and heavy cream. The Maillard reaction is a chemical reaction between amino acids and reducing sugars that occur when some foods are heated to high temperatures. It requires both proteins and sugars to occur. This reaction produces a complex mixture of compounds that give brown food its distinctive flavor and aroma. So, this is stage 2, giving your softball. The third stage, we are at firm ball, and the firm ball is around 245 to 50 degrees Fahrenheit, and it's the firm ball stage. Alright, here's my result for my firm ball. It's a little bit firmer than the softball, but not too crazy. Now we are at the hard ball stage, which is approximately 250 to 265 degrees Fahrenheit. And again, when you put this in a cold glass of water, it should form a hard, sticky ball. You can already tell it's a lot firmer than the last two. Eee. Oh yeah, and pretty much, you can see that's a lot firmer. We have finally reached going into our last two stages. We are at the soft crack stage, which is approximately at the 275 to 290 degrees Fahrenheit, and it goes into a soft crack because it stops forming balls into the glass of cold water, and it should go back to doing threads. But when this caramel is at room temperature, instead of being soft and bendable, it will break like crack. Hey, time for the truth. It did not come off my spoon, but if I hold it, it's very, very hard. You can hear the crunching sound of it is very, very hard. Alrighty, so our final stage is the hard crack. It should do pretty much the same as the last one. This would be used for breaking into caramel shards. Oh yeah.
Concluding my caramel experiment, demonstrating the different stages of caramelization through applied heat, we were able to see that the longer the caramel continued to boil and increase in temperature, the darker the caramel color became when more and more water was being evaporated during caramelization. The one unexpected result in this experiment was my Maillard reaction was supposed to occur during stage 2, where it would have started reaching a temperature for the reaction to occur. But the sugar started to brown while it was melting with the mixture of ingredients in stage 1. If I had used a different recipe, my results would have been different, possibly showing a clearer result of the Maillard reaction.